Good day, students. Welcome to JSS 2 Basic Science, Term 3, Week 5. Today we study density and floating, concepts that explain why a large ship made of steel floats on water while a small steel boat sinks, why ice floats on water, why oil floats on palm soup, and why a piece of wood cut from an Iroko tree floats in the Niger River. These are not obvious facts, they require understanding density and Archimedes and Oppo's principle. By the end of this lesson, you will be able to define density and calculate it using the formula density equals mass/volume, compare densities and predict whether an object will float or sink, state Archimedes and Oppo's principle and apply it to calculate upthrust, explain why ships float despite being made of dense steel, and give examples of floating and sinking in everyday Nigerian context. Let us dive into the physics of floating. Density is defined as the mass per unit volume of a substance. It tells us how much matter is packed into a given space. Formula: density, D, equals mass, m/volume, V, or D equals m/V. SI unit of density, kilogram per cubic meter, kg/m superscript 3. Also commonly used, g/cm superscript 3, grams per cubic centimeter. Conversion: 1 g/cm superscript 3 equals 1000 kilograms per cubic meter. Density of water equals 1 g/cm superscript 3 equals 1000 kilograms per cubic meter. This is the key reference value. Floating and sinking, the rule is simple: if an object and Oppo's S density is less than the density of the liquid it is placed in, it floats. If an object and Oppo's S density is greater than the liquid and Oppo's S density, it sinks. If densities are equal, the object is neutrally buoyant, hovers at that depth. Examples: wood, density is almost equal to 0.5 to 0.9 g/cm superscript 3, less than water, 1.0 g/cm superscript 3, floats. Steel/iron, density is almost equal to 7.8 g/cm superscript 3, much greater than water, sinks, but a steel ship floats. Why? Palm kernel oil, density is almost equal to 0.9 g/cm superscript 3, less than water, oil floats on water. Ice, density is almost equal to 0.92 g/cm superscript 3, slightly less than liquid water, 1.00 g/cm superscript 3, ice floats. This is extremely important ecologically. Ice forming on the surface of lakes insulates the water below, allowing aquatic life to survive in cold climates. Section 1. Calculating density. Density equals mass/volume. Rearrangements: mass equals density times volume, volume equals mass/density. Worked example: a block of wood has a mass of 90 g and a volume of 150 cubic centimeters. Find its density. D equals m/v equals 90 divided by 150 is equal to 0.6 g/cm superscript 3. Since 0.6 g/cm superscript 3 is less than 1.0 g/cm superscript 3, density of water, the wood floats. Measuring volume of irregular objects, use the displacement method, Archimedes/overflow can method. Fill a container, measuring cylinder or overflow can, with water to the brim, place the object in the water, collect the water that overflows, volume of overflow equals volume of object. This works for solids that do not dissolve in water. Section 2. Archimedes and Oppo's principle and upthrust. Archimedes and Oppo's principle, discovered by the Greek scientist Archimedes, circa 250 BC. When a body is fully or partially immersed in a fluid, liquid or gas, it experiences an upward force, upthrust or buoyant force, equal to the weight of the fluid displaced. Upthrust, U, equals weight of fluid displaced equals mass of fluid displaced times G equals density of fluid times volume submerged times G. When an object is placed in water, two forces act on it. Weight, W, equals downward force due to gravity, upthrust, U, equals upward force due to displaced fluid. If W greater than U, object sinks. If W equals U, object floats fully submerged, neutrally buoyant, like a submarine hovering. If W less than U, when fully submerged object floats at the surface, it rises until it is partially submerged, displacing only enough water for U equals W. The object settles when the upthrust exactly equals its weight. So, a floating object displaces a volume of water whose weight equals the weight of the floating object. Section 3. Why does a steel ship float? A solid block of steel has density is almost equal to 7,800 kilograms per cubic meter, much higher than water, so it sinks. But a ship is not a solid block of steel. A ship is a hollow shell of steel, containing a large volume of air inside. The average density of the ship, total mass divided by total volume including air spaces, is less than the density of water. Therefore the ship floats. A steel ship can be loaded with cargo until its hull is submerged to the plimsoll line, the load limit marked on the ship and oppose, S hull. At this point, the weight of water displaced equals the total weight of the ship plus cargo. Nigeria and oppose, S Navy vessels, tankers exporting crude oil from Bonny Island Terminal, and cargo ships at the Lagos and One ports all float because of this principle. If a ship takes on water through a hole or flooding, water fills the air spaces, increasing the average density of the vessel above that of water, and the ship sinks. Section 4. Applications of density and floating in Nigeria. 1. Fishing industry. Nigerian fishermen in the Niger Delta use wooden dugout canoes, low-density wood, and calabashes, dried gourd, very low density, as floats for fishing nets. Nets are kept at the right depth using a combination of floats, lights, and sinkers, dense lead weights. 2. Hot air balloons and aerostatics. A hot air balloon floats in air because heating the air inside the balloon decreases its density. Air expands when heated, below the density of the surrounding cooler air. Upthrust from displaced cool air, weight of balloon system rises. Same principle as a ship in water, but in air. 3. Hydrometers. Lactometers. A hydrometer is a device that uses density differences to measure the concentration of a liquid. A lactometer specifically measures the density of milk to detect if it has been diluted with water. Adulterated milk is more common in Nigerian markets. The hydrometer sinks less deeply in denser liquids, more deeply in less dense liquids. 4. Life jackets. PFDs. A life jacket keeps a person afloat because it contains low-density foam or air chambers that reduce the average density of the person plus jacket system below the density of water. Essential for water safety in coastal and riverine Nigerian communities, Lake Chad, Niger Delta, Atlantic coast. 5. Submarines. Submarines control buoyancy by filling or emptying ballast tanks with seawater. Fill tanks. Average density increases submarine dives. Pump water out. Density decreases submarine rises. Total weight control without the use of engines. 6. Swimming. Human body density is almost equal to 0.95 to 1.0 g/cm superscript 3, very close to water. A breath of air reduces average body density slightly, making it easier to float. Fat tissue density is almost equal to 0.9 g/cm superscript 3, is less dense than muscle, is almost equal to 1.06 g/cm superscript 3. And bone is almost equal to 1.9 g/cm superscript 3, which is why people with higher body fat percentage float more easily. Density and floating calculations. Question 1. An object has a mass of 200 g and a volume of 250 cubic centimeters. Will it float or sink in water? Density of water equals 1 g/cm superscript 3. Calculate the density. Answer. Density equals mass/volume equals 200/250 is equal to 0.8 g/cm superscript 3. Since 0.8 g/cm superscript 3 less than 1.0 g/cm superscript 3, density of water, the object floats. Question 2. A steel ball of mass 480 g is fully submerged in water. The ball has a volume of 60 cubic centimeters. Calculate A. The density of the steel, B. The upthrust on the ball, C. The apparent weight of the ball in water. Take density of water equals 1 g/cm superscript 3, g equals 10 meters per square second. Answer A. Density equals m/v equals 480 divided by 60 is equal to 8.0 g/cm superscript 3. B. Upthrust equals weight of water displaced equals mass of water displaced times g equals volume times density of water times g equals 60 cubic centimeters times 1 g/cm superscript 3 times 10 is equal to 60 g times 10 is equal to 600 g cm/s superscript 2. Using SI, volume equals 60 cubic centimeters equals 60 times 10 cubic meter. Upthrust equals 60 times 10 times 1000 times 10 is equal to 0.6 n. C. Actual weight equals 480 g times 10 meters per square second/1000 is equal to 4.8 n. Apparent weight in water equals actual weight minus upthrust equals 4.8 minus 0.6 is equal to 4.2 n. For density and floating errors. Mistake 1. Thinking large or heavy objects always sink. Floating depends on density, not on size or mass alone. A large wooden log floats, a tiny steel marble sinks. A massive oil tanker floats, a small solid steel boat sinks. Mistake 2. Thinking weight and mass are the same. Mass is the amount of matter, kg, measured with a balance. Weight is the gravitational force on the mass, n. W equals mg, measured with a spring balance/scale. They are related but different quantities with different units. Mistake 3. Saying Archimedes and oppose. Principle only applies to fully submerged objects. The principle applies to both fully submerged and partially floating objects. A floating object displaces its own weight of fluid. Mistake 4. Saying oil floats because it is lighter. Oil floats because its density is less than water and oppose. S density and oppose, lighter and oppose, is a casual term that actually refers to density, not weight. A barrel of oil weighs more than a cup of water but still has lower density. Excellent work. Density equals mass/volume. D equals m/v, unit, g/cm superscript 3 or kg/m superscript 3. Water density equals 1 g/cm superscript 3 equals 1000 kg per cubic meter. Floating rule, density of object less than liquid floats, greater sinks, equal neutrally buoyant. Archimedes and oppose, principle, upthrust equals weight of fluid displaced. Floating object displaces its own weight of fluid. Steel ships float because their average density, including air spaces, is less than water. Nigerian applications, wooden canoes, calabash floats, life jackets, oil tankers, hydrometers, hot air balloons, submarines. For homework, using the formula D equals m/v, calculate the density of the following and state whether each floats in water. Density of water equals 1 g/cm superscript 3. A. Object A, mass 120 g, volume 200 cubic centimeters. B. Object B, mass 300 g, volume 150 cubic centimeters. C. Object C, mass 50 g, volume 50 cubic centimeters.